Before we show you how to insert KLV metadata packs in live video with our toolkit, let's review what a KLV metadata packet actually is. KLV metadata packets are defined by SMPTE and are a structure shown here in this area of the slide. It's signified by an auxiliary data flag, a data item description which identifies it as a KLV pack, and an SSID which identifies it as a type 2 pack, which means it's up in the bank space of a video frame. The user data word contains the KLV packet itself, which is structured with 2 bytes, 3 bytes actually, that are a PSC and a message ID to help you identify individual messages in the packet, in the line, and also to identify pieces of a total message that is comprised of several packets. What we're interested in is the key, the length, and the value, the key being a 16-byte number, the length telling you how many bytes the payload is, which is the value. The payload value can be anywhere from 1 byte up to a limit of 235 bytes inside of a single packet. We have a key template that we offer that is a tool where you can structure data to fit in a KLV packet, and it will allow you to provide labels to it that you can be able to use later with some of our other software to see data collected in human readable form and understand what each data is. Assign space for it in terms of the number of bytes and offset into this memory space, and to assign it what that data represents, whether it's integers signed or unsigned, whether it's floating point numbers, whether it's ASCII text or just a binary block. You can do that all with the key template, as we've described in other videos. So we offer tools that allow you to structure those keys as we have with the template, and then use the key with software we call the data concentrator that can take raw data in from a myriad of sources, such as a data acquisition system, a data logger as is shown here, or individual sensors that are connected to a PC. You can identify those sources to the data concentrator and tell it on what ports that data is arriving, and then how to parse those ports or those records, and then map each individual element of data that you're concerned with and map them to the structure you created for the key. So the data concentrator then can be set into a mode, once this is set up, to receive the data asynchronously from whatever source you have and automatically fill the key with the data received as an individual sample. Then you can tell the data concentrator, once it's doing that, to wrap a sample, a payload packet, in ITS insertion commands and send them out at some rate. It can be anywhere from 1 time a second to 200 times a second, and that also is asynchronous. With one of our time, text, and metadata inserters, or the 6520 video recording instrument, you can take in real-time live video from a video source, a camera, receive that video, and in the start of the video frame, on each video frame, it will take the last full packet of payload that it received from the data concentrator over Ethernet and insert that on line 9 right after the timestamp on every frame as it comes in. So then the sample payload data then is payload related to the arrival of the frame to the inserter or the recorder at real time. And the end then is to have a video stream output from this particular device that now has metadata sampled at the frame rate and now is fused together, and that's why we call this video and data fusion process. The inserter products are pass-through products, meaning video comes in and goes out And the total latency in doing this is only 4 microseconds. We don't do any frame buffering or compression or anything. So the imagery that comes out here is the imagery the camera gave us there, and the data is sampled at the frame rate. Once you have the data, you can use the key template to inform a key test software what that structure is, and you can put in sample data. If there's numerical values here, if you check each of these boxes or any boxes you choose, every time you tell the key test software to send a packet, a payload packet, it will increment the numbers here. So you have live numbers moving around. If you have ASCII text, you can put the text in, and now the payload packet will contain this exemplary data and any other fields that you filled in. Wrap that in insertion commands just like the data concentrator does, and sends it to an inserter or the recorder, in which case you could use that to test that the key works long before you're using live data from live sensors and data acquisition systems. So to go back to the data concentrator a minute, you can see in total what happens is data can be selected from a device. The data acquisition system may be giving you many fields of data inside of a single record that comes to it. But you can choose to select data of interest and map those to fields of the key that you've designed, and you can do that separately from different devices that are all connectable to the same PC that's running the data concentrator software. When that's done, the data concentrator will take all that data, parse it, and fill the fields of the KLV structure and put it in that envelope. Then that envelope is in turn put in the insertion commands, and then that's streamed out and sampled by the video. So even if packets are coming to it at 200 times a second, the last packet any of our inserters will receive at the time a vertical sync comes, that's when that packet then will be put into line 9 of the video frame. So you're effectively subsampling down to the frame rate of the incoming data payloads, and they're put up in the frame, and you end up with a video stream now with the data in it. To give you a little bit more detail, you can see that you can pick off the values you choose from any one of these devices, and you don't have to map them in order. They can be randomly mapped so that they're put in a structure that makes sense to you at the time you're trying to evaluate this data as it comes in. It will be mapped to that, form payloads, and as we said, put it into, in this case we're showing a recorder from live video coming in, and when you're done you have your data in the bank right after the microsecond timestamp, which is a KLV pack that all of our HD SDI equipment is capable of doing at your command. Now to take a look at a block diagram of what a whole system might look like. You have a video source, a camera, taking SDI into a recorder. The recorder can capture a clip to SSD. It can capture a clip to DDR, which is the volatile memory inside the recorder. The volatile memory can be set up to be a loop recorder of some length, depending on the video format, from 10 seconds to even 600 seconds of video. The post-event time can be decided upon by you. So you can now create a design that says, I'm capturing a clip, and exactly when the event triggers that clip can be at the beginning of the clip, the end of the clip, or anywhere in the middle. Now that clip then is saved. And one of the beauties of this system then is if you're sending metadata to it in any form, but certainly with our data concentrator, you're sending payload packets over Ethernet to the recorder. While it's in this loop mode, it's capturing the data. So when you save the clip that you captured from an event, it has the data relevant to the time the event occurred. So you can now see the data surrounding the event and the video surrounding that same event, all synchronized together. Likewise, if you're just straight recording to the SSD, you can record a clip by starting and stopping, and if data is coming to it from a data concentrator or equivalent, that data will be captured along with the video and saved on the SSD. At playback time, you can tell the recorder then in the playback channel to actually decode the video, because it is actually a full inserter that is in decode mode all the time. So it can play back the video in SDI, and it's all uncompressed, so the video captured here is the video you see there. In addition to that, it can also extract and parse the metadata in accordance with your key that you designed with the key template, which can be sent to the 6520 with its utility, or GUI utility that we have for it. And it can then overlay that data on the video. This little sample that you see here has some overlay of that data. And you can see that data play along with the video as it was captured. With the recorder, you can actually single step and go backwards and forwards, so you can actually watch the data and the video together. You don't have to play it that way, and in fact, when it's doing this overlay, it's not affecting the video that was captured. You still have a clean frame. This is just being done contemporaneously as playback is occurring. You also can use download video and tell download video to send that data over UDP packets to a PC, and with the PC then the metadata and video and uncompressed image data are all captured to the PC, and we'll describe later in the part 2 of this video sequence. We will show you that you can use download video to capture the video, see the video on a PC, and play the data and observe it synchronized to each video frame. Thank you for listening.